my homework and to study guide. It's not right back to back. So I'm just going over a few of these real quick.
Every time.
I would hate you so much.
Okay, a couple things to kind of remember as we start talking about work. What's the formula for work? Force times distance. So work is force times distance. We had or if you've had physics, this is a lot of physics. Okay, so work is force times distance. Okay, work is measured in two things. Force is newtons, work is in joules. So one way work is measured is in joules, and that is newtons per meter. And newtons is a measure of force. So there's a couple ways you may see work depending on how they kind of give you the other information. If they give you in newtons a meter, or if they give you in foot pounds, you kind of decide how you label work. So work can either be labeled as joules, or work can be labeled as foot pounds, depending on how they give you the distance and the force and all that stuff. Okay, so as I look at example 1, you had some. These are kind of similar to what you did yesterday, but just kind of some more examples to look at. So example 1A, how much work is done lifting a 1.2 kilogram book off the floor to put it on a desk that is 0.7 meters high? So first thing, when I give you something in kilograms, kilograms is measuring what? Weight, but it's measuring not force. Kilogram is measuring mass. So when I give you something in kilograms, it is measuring mass. So there's the mass. The mass is 1.2. Okay, I am lifting. So if I think about the force, how much work? First thing I need to do is find the force. So this is part A. Force is formula for force. Physics people? Mass times acceleration. So my mass is 1.2. My acceleration, if I am lifting the book up, the acceleration due to gravity is what? 9.8. So my force, if you multiply those, will be 11.76, and that is newtons, because if you notice, it is giving you into meters. So anytime we're talking about meters, kilograms, the metric unit is going to be measured in newtons. So force is measured in newtons. Okay. Now I want to know the work. So once I know the force, the second part is to find the work. Work is force times distance. My force we just found to be newtons, so that's 11.76. And my distance has to be in meters because it's newtons per meter. And they already give it to me in meters, 0.7. So my distance that I'm moving that book, that I'm exerting a force of 11.76 is 0.7. And if you multiply that, that is going to be 8.2 what? Joules. Okay? So the math isn't super complicated with some of these. You just kind of have to know, okay, this is telling me mass, this is telling me acceleration, blah, blah, blah. You kind of need to know where to plug stuff into. Okay, any questions on that? Now B, it's the same idea, except I want to know how much work is done in lifting a 20-pound weight 6 feet off the ground. Now pounds is measuring what? Force. Pounds is measuring force because it is taking into account It is taking into account the force of gravity on your body. If you measure if any of you take your weight, you are taking the weight of the gravity pushing down on you. So it is taking into account the force of the gravity pushing down on you. Does that kind of make sense? I had to go to Mr. Miller to explain that because it had been a while since I've taken physics. So pounds is measuring force, kilograms is just giving you a mass. Okay? So 20 pounds, my force is 20 pounds. So if I want to know the work, it's force times force times distance. So my force is 20, my distance is what? 6. Now that doesn't have to be in meters because there's two ways to measure work. Newtons per meter. So if I was dealing with a force of 5 newtons, or if I was dealing with a force in newtons, I'd have to have it in meters. But now I'm dealing with a force in feet. So my distance, in pounds, so I need it in feet, which it already is. So 20 times 6 is 120 foot-pounds. So not really a ton of calculus stuff yet, just kind of getting you into work and force and all that stuff. Okay. Questions on that? Okay, those are pretty straightforward for the most part. On the homework, the first ones are kind of like that. We're going to skip example 2. Next, we're going to look at example 3. Force of 40 newtons is required to hold a spring that has been stretched. I didn't have spell check on my computer last year when I did this. Has been stretched X meters beyond its natural length of 10 centimeters to a length of 15 centimeters. How much work is done in stretching the spring from 15 centimeters to 18 centimeters? Okay, I believe there was one on your notes yesterday like this when we were talking about stretching a spring. What law am I going to use? Hooke's law. So we are going to look at Hooke's law. So Hooke's law looks like... This was on your notes yesterday, right?
Yeah.
Okay. So f of x, so this is kind of review, which is fine. F of x equals kx. Okay, f of x is going to be your force. So Hooke's law is how you find the force. So it's not going to tell you work. You'll have to take it a step further to find work, but it will give you your force. K is called my spring constant, which is fine. We've always kind of referred to K as a constant before anyway. That's just a spring constant. And X is meters. So if you need to underline it, whatever, we need to deal with meters. So it is meters beyond the natural state. So be careful with this because when I'm measuring using Hooke's law, it needs to be the meters beyond the natural state, and it will tell you what the natural state is. So I'm looking for the meters beyond that natural state. Okay, so let's go ahead and look at these. First thing we need to do is we always need to find the spring constant. So whenever we do Hooke's law, they may tell you the spring constant, but usually we're going to have to find the spring constant first. Which is my K value. Okay, it's kind of like direct variation. You've done direct variation before, algebra 2, maybe a little bit in pre-calc, so it's kind of the same idea. You need to find K, and they're going to give you enough information in the first sentence or somewhere in there comparing two things that will allow you to find K. So if I look at Hooke's law, f of x equals kx. And if I look at the first thing they tell me, a force of 40 newtons is required to hold a spring that has been stretched x meters beyond its natural length of 10 centimeters to a length of 15 centimeters. So using that information, I need to find K. F of x is my force. What do they tell me my force is? So the force is 40 when x is the meters beyond the natural state. So what will my x be? If the natural length is 10, it's stretched to a length of 15 centimeters. So what would x be? However, it has to be in meters. So let's go ahead and convert everything that's in centimeters to meters real quick. Okay, 10 centimeters to meters. How do I convert that? 2 to the left. So to go from centimeters to meters, I move the decimal point 2 to the left. So that's going to be 0.1 meters and 0.15 meters. Because x is the distance from the natural state in meters. So my x value is going to be what? What is the distance from the natural state to the what I stretched it to? 0.05. The distance between 0.1, the natural state, and 0.15 is 0.05. So that is going to be my x value. Or 0.05. Sorry, I said 0.15. 0.05. That makes sense? Okay, divide by 0.05. So we are going to have 40 divided by 0.05, which is going to give you 800. So my spring constant is going to be 800. Okay? Any questions so far? Okay, step 2, we need to find the work. So here's another way to find the work. This is how you find the work if you have things that are changing. Okay? If your force is going to be changing, you're going to have to set up an interval. And there was a couple examples we did yesterday like it. So my work, I'm going to have to set up my interval because my force is going to be changing. So as I look at this, my interval, I'm going between, I want to know how much work is done in stretching the spring from 15 centimeters to 18 centimeters. Okay, so my interval is going to be what? Okay, now be careful, I want to find work. So work always has to be newtons per meter. So it always has to be in relation to meters. So if I look real quick and change 15 and 18 to meters, that's going to be how many meters? 0.15 meters and 0.18 meters. Because work always has to be measured in meters. 0.15 meters, 0.18 meters. And let's go ahead. Now be careful with this. We are looking for a distance. So my interval is going to be the distance from the natural state. So as I look at my interval, we are going to be looking at the distance that I'm moving past the natural state. So if I'm going from 15 centimeters to 18 centimeters, it has to be in relation to the natural length. So it's going to be 0.15 to the natural length of 0.1 is going to be what? .05, because it has to be in relation to the natural length. So I'm starting at 0.15 meters, but the distance from the natural length is 0.05. So it's 0.05 to what? 0.08. So be careful because your interval always is in relation to the natural length. Because the natural length is the resting length. Okay? If you think of a spring, okay, it's not going to start at 0. It's going to start at some natural length. I wish I had a spring with me. Maybe I'll try to bring one. But like I have a spring on my porch swing. So the spring starts at a natural length. It doesn't start at a length of 0. It's like some starting length. So you always have to be in relation to that natural length or that starting length. Okay? So it's 0.05 to 0.08 is actually the distance you're moving. Does that make sense? Okay, sort of. Okay. Now, as I look at this, work is, okay, as I look at work is going to be 800 x, okay, that's going to represent the force, so 800 x dx, and that will give me the work. So that will give me the force done over a period of time. So this actually is representing work or force times distance, which is the work formula, but my distance is 0.05 and 0.08. It's not a constant, and my force is changing with how far I'm going. So that's why we have to set up an interval. Okay? So as I set this up, we're just going to take the integral of this. So we're going to have, what's the integral of 800x? 400x squared from 0.05 to 0.08, and just plug 0.08
squared minus 400.05 squared. I'm using way too many parentheses, but whatever.
And if you plug that in your calculator, you will get 1.56. And this will be what? Because I'm going to be kind of picky about labeling. That's going to be labeled as what? What did I find? Right, which is what? Joules. I'm looking for work, and I'm dealing with newtons and meter, so it's in joules. Okay, questions on that? Okay, I'm just going to do 2 more examples. Okay, example 4. Let's see, these are kind of tricky. A 200-pound cable is 100 feet long and hangs vertically. Is there one on the notes like this? I'm not sure there was. That's gross. I went to take a sip out of my straw and I put my mouth over my pen. It happens. Okay, a 200-pound cable is 100 feet long and hangs vertically from the top of a tall building. How much work is required to lift the cable to the top of the building? So let's draw a picture. Here is my building. They do not tell me how tall the building is, so I'm not going to label that. I have a 200-foot cable that is 100 feet long, a 200-pound cable that is 100 feet long and hangs vertically from the top of the building. So here's my cable. It's hanging down over the building. How much work is required to lift the cable to the top of the building? Okay, so let's look at this. First thing I need to find is I need to find the force that is exerted per foot. So first thing I know the force is what? So like we talked before, what's going to be my force over the whole thing? 200 pounds. But I need to find the force per feet or per foot, because as I lift up the cable, so if I'm standing on a building and I'm lifting up the cable, is there always going to be is that 200 pounds of force always going to be exerted on the same 100 feet? Because as I wheel up or pull up the cable, and I have cable standing, but like if you think about it, it kind of makes sense. If I pull up a cable, and the cable, so I'm pulling up a cable and it's like laying down beside me, is there any force necessarily on that cable that's just hanging out beside me? No. So your force is going to be depending on how many feet is hanging down. So we need to find the force per foot, or the pounds per foot. So if I think about it, how do I find how much force is exerted per foot? Yeah, 200 divided by 100. So it is 2 pounds per foot, because it is changing. So as I lift up the cable, there's not going to be any weight necessarily for the, not necessarily, but the force isn't going to be acting on it if it's just sitting there. Okay? So 2 pounds per foot. Okay, my force, if I think about it, it is 2 times delta y. Let me explain that. So 2 delta y is how I'm going to represent my force. Delta y is my, if I think about labeling it, this is going to be my distance. So as I pull up my cable, the y value is how is changing. So how it's changing vertically. So that's why I have a dy, the change in y. So it's going to be 2 times whatever the change in y is. Okay? So as I think about this, my distance is changing. So to find my work, I'm going to have to use an integral because my distance is changing. I'm pulling it up. Now let's think about what distance am I going? I'm going from what to what? So I'm moving that cable. So first of all, that cable starts at what? And it's going to go to what? How far am I moving that cable? If it's 100 feet and it's hanging off. So if I start it and it's 100 feet hanging off and I pull it up, how far am I going to move that cable? Until it's all the way to the top. Do I?
Is the whole thing?
Mm-hmm. Lift the cable to the top. 0 to 100. So that distance that cable is going to be moving is 100 feet because it's hanging off the side and I'm pulling all of it up. So it's going a distance of 100. Okay, so that is going to be my force, 2y dy. So that is going to take into account the change in y. So I need a y to take into account is 2 times how far up is gone. And I look at taking the integral, what's the integral of 2y? Y squared. 0 to 100, so 100 squared minus 0 squared, which you don't need, is 10,000. So that is my work. So I had to set up an integral because it was changing. Because the force is going to be changing as I pull up the chain. And that is going to be measured in what? Foot-pounds. Not newtons, because I'm not measuring it in, or not joules, because I'm not measuring it in newtons or meters. Okay. Any questions on that? Okay, we're going to skip 5. Let's look at 6. An aquarium 2 meters long, 1 meter wide, and 1 meter deep is full of water. Find the work needed to pump half of the water out of the aquarium. Use the fact that the density of water is 1,000 kilograms per meter cubed. So if I look at my aquarium, however you want to draw it, so something like that. That's too far out. Sorry, I can't draw very well. There. Something like that. So there's my aquarium. It's 2 meters long, 1 meter wide, and 1 meter deep. I kind of drew that line extra long, whatever, it's fine. Find the work needed to pump half of the water out of the aquarium. So as I look at it, I want to know work. Okay, they do not tell me the force because it is being measured in meters. Does not tell me the work or the force. So I need to find the force. Mass times acceleration. Okay? So as I think about mass, I need to know what is the mass of the water. And it is completely full of water. So if I want to find the mass of water, mass is going to be measured in what? Kilograms. Okay? So I need to know how many kilograms of water I have in that tank if it is full. So what do I need to do to figure out what is the mass of that water, how many kilograms of water I have in that tank. Not divide it. It's 1,000. Yeah, it's 1,000 kilograms per meter cubed. So it's 1,000 times how many meter cubes I have, or what the volume is. So what's the volume of this rectangular prism going to be? 2. 2 times 1,000. So I'm going to have 2,000 kilograms of water in that tank. So that is the mass, because you have to take the volume times 1,000, because that's how many kilograms in a meter cubed, times my acceleration. And if I'm pumping that up, I'm going to be dealing with gravity pushing down on it. So acceleration due to gravity is 9.8. So my force, if I multiply it, is going to be 19,600 what? Force measured in newtons. Now obviously not going to be pounds because I'm dealing with kilograms and meters. So it is newtons. So force is newtons or pounds. Okay, that is the force. It wants to know the work. Okay, my force is going to be changing because as I pump the water out, the force is going to be kind of changing because I'm going to have less mass in there because I'm going to be pumping it out. Does that kind of make sense? It's kind of weird. I know this is kind of weird to think about. Don't overthink it too much. This was kind of a struggle, one of the areas that I struggled with trying to figure out. But since the force is going to be changing, because your mass is going to be changing because you're pumping water out, so your force is going to be changing. So that's why we have to use the integral. So as I think about this, okay, I am pumping the water out. So you want to think about, if I'm pumping the water out, something like this. So I'm pumping the water out. Okay? What distance am I moving this? And it has to be in meters, which it already is. So I'm going from a distance of what to what if I'm pumping half of the water out? 0 to a half. So you kind of think of it like upside down. I start at 0 at the top. If I'm pumping it out, I start at 0 at the top because I haven't went any distance, and then I'm pumping half of it out. So it is a half because it's 1 meter. The whole thing is 1 meter. So if the height would have been 10 meters, it's 0 to 5. But since it's 1, it's a half. So 0 to a half. That is your force. 19,600 times y, because that is how my vertically is changing. So I have to put a y on there. That's going to give me the distance. If I take the integral of this, what's the integral of 19,600y? 9,800 y squared. From 0 to a half. And then plug in a half. 9,800 1/2 squared. So 1/2 squared is a fourth. So that times a fourth is 2,450 joules, because this is work. Because it's newtons per meter. Okay, questions on that? Hopefully that helps a little. Does that help a little bit? Okay, that should help you some with the homework. Okay, so I would. There's going to be some work problems on there. So if you're struggling with work problems, I mean, I guess your first priority should be the study guide, but I would try to do some of the work problems on the homework because you're going to see them again. So I would be